Welcome to Maths with EJD. Still on numerical analysis, we now switch to interpolation and approximations. And the first topic we'll be looking at under that will be broadly polynomial interpolations. And there are two types of that. Polynomial interpolation. So there are two aspects of that. The first is the Lagrange polynomial interpolation and the Newton divided difference. Newton divided differences. These are the two methods or forms of polynomial interpolation we have. So in this video, the focus is on Lagrange polynomial interpolation. Lagrange polynomial interpolation. Because we know generally polynomial is in the form, generally a polynomial is of the form P of x equals, say, ax raised to power 1 plus bx raised to power 2 plus cx raised to power 3, and so on and so forth until you get to whatever. It just goes on like that. So for us to be able to, as far as polynomial interpolation is concerned, right, let's say polynomial interpolation involves finding a polynomial that passes through a given set of data points, a given set of data points. So sometimes you have a set of data points and you want to turn it into a polynomial. So polynomial interpolation is the best place for you. Then the Lagrange interpolation formula, interpolation formula provides a method for constructing such a polynomial. So if you have some data points and you want a polynomial out of it, so you can use the Lagrange interpolation formula for constructing such a polynomial. Especially useful when the data points are distinct. Okay, the Lagrange polynomial P of x, Lagrange polynomial P of x of degree n minus 1 passing through n distinct points, so say points x naught, y naught, x0, y0, x1, y1, all of that till you get to xn minus 1, yn minus 1 is given by P of x equals summation from I equals 0 to n minus 1 yi li of x. So this is the Lagrange polynomial formula right now. where Li of x are the Lagrange basis polynomials. Lagrange basis polynomials defined as Li of x equals all the products of this for 0 less than or equal to j less than or equal to n minus 1, where j is not equal to I, for x minus xj all over xi minus xj. So this is the formula for Li. Never mind that it's looking all complicated. Well, we take an example, it will be clear. Okay, so x minus xj all over xi minus xj. Now, each Lij of x is constructed so that Li of xj equals 1 if I is equal to j, and Li of xj equals 0 if I is not equal to j. So this ensures that the polynomial passes through all the given points. Okay, so let's look at practical example. Find the polynomial interpolation. Find the polynomial interpolation that passes through the points 1, 2, 3, 4, 4, 3. Okay, just 3 points. Hey, of course, if we want to deal with that, right, we can have something like this. Okay, first of all, we have I, we have xi, and we have yi. Okay, so by that we simply mean that when I is 0, okay, we have x naught, x0, that is 1, y0, that is 2. And then we have when I is 1, we have 3 for x1, and we have 4 for y1. And lastly, when I is 2, so it means x2 is 4 and y2 is 3, like this. So it means that any polynomial we get should pass through these 3 points. Now with this we can go ahead and say we remind ourselves of the general formula. So the general form for the polynomial is P of x equals y naught, from what we had the other time, right? From the very beginning. So yi lix, right? So that we have y naught L naught of x plus y1 L1 of x plus y2 L2 of x, like that. So because, I mean, we have 0, 1, 2, basically. So we go 0, 1, 2. So where y naught is equal to 2, you see y naught, this is y naught, that's 2. Y naught is 2, y1 is 4, y3, y2 is 3, right? So where y naught is equal to 2, y1 is equal to 4, and y2 is equal to 3 are the corresponding y coordinates, are the corresponding y coordinates of the given points, of the given points. Then we have L naught of x, L1 of x, L2 of x are the Lagrange basis polynomials, are the Lagrange basis polynomials. Lagrange basis polynomials. Okay, so let's go ahead and talk about so the step 1 we're going to take here will be this. Calculate the Lagrange basis polynomials. And this is how that goes. We have A under that. For L naught of x, which corresponds to, for L naught of x, corresponding to the point 1, 2. Now see how that goes from the formula, right? If you remember the formula of there for L, so it's this Li of x is multiplication of x minus xj over xi minus xj, as j lies between 0 and n minus 1. So what that is going to be rendered as here would be this, that L naught of x will be equal to L naught of x will be equal to x minus, this is corresponding to 1, 2, right? L naught of x. So we have 3, 4. So x minus xj over xi minus xj. So our I here is actually 0, right? So we have x minus, see the 3 points we have. So 2, 3, 4, like that. So we're going to have x minus 3 multiplied all over x naught minus, all over x naught minus 3 multiplied by x minus 4 multiplied by x naught minus 4. So so if I'm going to generalize the formula, right, this is going to be the product of, okay, I guess I can just go ahead, right? Since this noise x all over x minus x1, we are focused on x naught. So that'll be x minus x1 all over x naught minus x1 multiplied by x minus x2 all over x naught minus x2. That's basically the idea here. So don't forget, this is what we are looking at. So x naught, so since our focus is here now, so we are going to have x naught, x minus x1 divided by x naught minus x1. Then we are going to have x general x, right, minus x2 divided by x naught minus x2. That's how that actually works. So because we are talking about L naught, so that means that L naught of x is going to be x minus, our x1 here is actually 3, then all over x naught itself is 1 minus 3, then multiplied by x minus x2. Our x2 is 4 all over x naught again. That's 1 minus 4. So x minus x naught, which is 1, divided by x naught minus x1. Okay. Then we have x minus x2. That is 4 divided by x naught minus x2. So that's how the formula goes. And then we can tidy this up to have L naught of x equals x minus 3 divided by minus 2 times x minus 4, x minus 3. Then this is x minus 4 divided by minus 3 down there. Then minus times minus is plus. So we see that L naught of x is equal to, this is more like 1 over 6 into x minus 3 into x minus 4, because minus and minus is plus. So we have 1 over 6 into x minus 3, x minus 4. So that goes. Then B now, B for L1 of x corresponding to 3, 4. Again, we now need L1 of x. So that means you're going to have x. So you are going to skip that 1. So this will be x minus x naught all over x1 minus x naught multiplied by x minus x2, because we are talking about 1. So the 1 will be down. Then at the top, we just have every other thing we don't have. So that will be x1 minus x2 now. So like we know, L1 of x is equal to x minus x naught. Again, x naught is 1. So we have x minus 1 all over x1. That this is x1. Okay, so that would be all over 3. That is 3 minus x naught. X naught is 1. Yeah, x naught is 1 multiplied by x minus x2. Our x2 is 4 divided by x1. X1 is still 3, right? X1 is 3 minus 4. So this is x naught. This is x naught. This is x2. Because we are at this point now, that one, the 3 only just, so we have x minus 1 over x minus 3 divided by, x minus 1 divided by x minus 3. No, yeah, x minus 1 divided by 3 minus 1 times x minus 4 divided by 1 minus 4 divided by 3 minus 4, since we are focused on x1 here. So here again, we have this, and that will be x minus 1 all over minus 2 times x minus 4 divided by minus minus 1. So that's L1 of x, right? So overall, L1 of x is equal to 1 over 2 into x minus 1 into x minus 4. So I think we need to take note of all this. This is L naught of x. This is L1 of x. We're going to put all of this together later. Then we go for the next one. That's like our C now, where we talk about L2 of x. So for L2 of x corresponding to the point 4, 3. So again, we have L2 of x, which will be equal to x minus x naught, because we are talking about 2 now, divided by x2 minus x naught, x2 minus x naught, multiplied by x minus x1. So that's 2, we skip it. It only appears under, so we have x2 minus x1 now. So L2 of x is equal to x minus, our x naught in this case is 1, okay, all over x2. X2 itself is this 4 here. This is our x2 now. So this is x2. So that's be 4 minus 1, then multiplied by x minus x1. So x1 is 3 divided by 4 minus 3 now. So we have L2 of x to be equal to x minus 1 all over minus 3 times x minus 3 all over 1. So that's going to have a negative value. Oh, is that, 4 minus 1 is 3. Okay, 4 minus 1 is 3. So the value is it's positive. So it means that L2 of x is equal to 1 over 3 into x minus 1, 1 over 3 into x minus 1 into x minus 3. So with that, now we still have L2 of x. Okay. So we have everything now. So let's go to step 2. So step 2, we have found all the basis polynomials. So step 2 is to substitute into the Lagrange, substitute into the Lagrange interpolation formula, So generally, we know the formula is P of x equals, what's that now? Y naught, L naught of x plus y1, L1 of x plus y2, L2 of x. So again, we have our y naught, y1, y2 up there. So this is y naught, y1, y2, just like this is x naught, x1, x2. So we have 2, 4, 3, right? 2, 4, 3. So that P of x now is equal to 2. L naught of x was what we got the other time as 1 over 6 into, so L naught of x, that's 1 over 6 into x minus 3, x minus 4. So 1 over 6, x minus 3 into x minus 4 plus y2, y1 is 4. That's 4 multiplied by y1 of x, multiplied by L1 of x. L1 of x is 1 over 2, x minus 1, x minus 4. So 1 over 2, x minus 1, x minus 4. Then y2 is 3 multiplied by L2 of x, which we just get. That's 1 over 3 into x minus 1, x minus 3. So 1 over 3 into x minus 1, x minus 3. Like that. Okay. So with this now, we can tidy things up. Is L2 negative? Is L2 supposed to be negative? This is 4 minus 1. L2 of x. L2 of x is positive. What about L1 of x? Okay, L1 of x. L1 of x. Okay, yeah. Sorry. So L1 of x, this is 2, not minus 2. So we're going to have, this is actually minus half. So the L1 is minus half. Thank God I quickly saw that. So L1 is minus half. How do I do this? Let me find a way to squeeze that in. So we have 4 multiplied by minus 1 over 2 here. Let me distinguish that. 4 multiplied by minus 1 over 2. All right. So we can go ahead now and tidy things up. So we have P of x equals 2 here is 1, 2 here is 3. 3 down here. So we have 1 over 3 into x minus 2, x minus 4. Or maybe let's just expand straight to save time, okay? That can be easily expanded. So we'll just use the fast way of doing it. So to do this, we just say x times x, that's x squared. Then minus 3x minus 4x, that's minus 7x. Then minus 3 times 4, that's plus 12 straight. Then 2 here is 1, 2 here is 2. So we have minus 2 into, again, x times x, that's x squared. Then minus x minus 4x, that's minus 5x, I believe. Then minus 1 times minus 4, that's plus 4. Easy peasy. So 3 cancels out. So we have plus x times x. So x times x is x squared. Then minus x minus 3x, that's minus 4x. Then minus 1 times minus 3, that's plus 3, like that. So we have P of x equals, so we have 1 over 3 x squared minus 7 over 3 x plus 4, 1 over 3 of 12. Then here we have minus 2x squared plus 10x minus 8. Then here we have plus x squared minus 4x plus 3. Okay, so we can tidy things up. So P of x is equal to, so for the x squared now, we have 1 over 3, 1 over 3 minus 2. So 1 over 3 minus 2, right? 1 over 3 minus 2, then plus 1. That goes for x squared. For x, we have this, and this. So that means just a plus here. So we have minus 7 over 3 plus 10 minus 4, and that goes for x. Then for the constants now, we have this, this, and this. So that is plus 4 minus 8 plus 3. 4 minus 8 plus 3. Okay, so P of x now is equal to, let's say 2 over 1, like this. So LCM is 3. So 3 in 3, 1. So we have 1 minus 1 in 3, 3 times 2, 6, plus 3. All of that into x squared. Then plus LCM here is 3 again. So we have minus 7 plus 30, then minus 12, I believe. Yeah. So all of that into x plus 4 minus 8, minus 4 plus 3. That's minus 1. So that goes. So we have P of x equals 3 plus 1 is 4. I mean, 1 minus 6 is minus 5 plus 3. That's minus 2 over 3 x squared. Then we have 30 minus 19, right? That's 11. So that's plus 11 over 3x minus 1. Okay? So this turns out to be the extrapolation, the polynomial, the Lagrange polynomial for those 3 points we have. Okay, so we can then conclude, that therefore, thus, the Lagrange interpolation polynomial for the points, 1, 2, 3, 4, 4, 3 is P of x equals minus 2 over 3 x squared plus 11 over 3x minus 1. Okay, so that's the result we get in this situation. Okay, so that's the Lagrange interpolation polynomial for the given points. All right, so as usual, I like to talk about the Python implementation of these things. I want this to come out good. Yeah, so that's the Lagrange polynomial. So this is the polynomial that passes through. So this is the polynomial. This is the polynomial that passes through, the given data points, So you can even check that. For instance, if you put 1, if you put 1 for x, you should get 2. Let's try. So if you put 1 here, that's 4. So that's minus 8 over 3 plus, put 1 here again. So that's minus 8 over 3 plus 11 over 3, right? That'll be minus 3 over 3. All right, minus 3. No, this is, if you put 2 here, that's 4 squared. So that's minus 8 over 3. No, you're putting 1 actually. So if you put 1 here, that's minus 2 over 3 plus 11 over 3. That's 9 over 3 automatically. Then minus 1. So 9 over 3, that's 3. 3 minus 1, that's simply 2. So that makes it correct. So if you, I'll just flash the Python code for this so you can have an idea what that looks like. So this is what the Python code looks like. So the view show the line numbers. So here you just declare your points, and this is where you define the Lagrange basis polynomial function, how it all goes x minus xj over xi minus xj, and the interpolation happens around here. So you just define this. So you can study this properly to understand how that works. So if I run this, it just gives me the result. So this is particularly good if you have many more data points. Like if you have the data points increased, like if you're working with a big data science project, you could actually use this. So the code will be useful in that situation. So that's how that goes. Thank you for listening all along. If you have not subscribed, if you have subscribed to the channel, I think I'd like to start with that. Thank you so much for doing that. If you have not, feel free to um, feel free to subscribe to the channel and hit the notification bell so you can always get alerted each time a new video is released. And of course, um, comment, let me know how helpful these videos are for you. In fact, you can even you can try this for this polynomial, for the obtained polynomial, or the obtained polynomial. Okay, so with that polynomial now you can now try to get other data points. But this for the obtained polynomial, right? For the obtained polynomial, find 1 p minus 3, p minus 3, that means you just put minus 3 whatever you get, so you can now get other data points, because that's the essence of interpolation. Then find p5, and so on and so forth. So you can take that as a practice question. So comment your questions, try this and put your answers in the comments. Let me know. Let me also know how helpful these videos are for you. And let me also know if there's a topic you'd like me to teach or a problem you'd like me to solve. Then like and share so that more people can have access to this great content. So like, come your way again, keep doing math right. Now in the next video, I'll be talking about Newton divided difference for the same set of points. So you can see we arrive at the same answer using different methods. So you have all of those at your beck and call. You can choose the one that works best for you. Bye.